Bye, man. I don't think so. Anyone else is joining now.
Ma'am.
You guys can start with the discussion. Like you can complete it in half an hour or so. Like
No, actually the problem is this assignment. I am little bit confused, ma'am. Actually, so I need someone's help. So the other people are not joining. I don't know why. If they are there, means, like anyone did this the assignment answers. It one
you can start sharing the screen and discuss, Kiran.
but I am not sure. But anyway, I will start the start. Yeah, now you can see my screen.
Kiran.
Now,
Yes.
okay, we'll start with assignment 12. For this one, if R is the radial distance from crack tip, Hutchinson, Rice, and Rosengan showed that J integral to remain path independent, the product of stress and strain near the crack tip must vary as a function of this 1 by R. This was in the lecture. Yeah, if you refer to the first lecture of this week, so it's written there. J characterizes characteristic condition in a nonlinear elastic material, Hutchinson Rice. They showed that in order to remain path independent, the strain must vary as 1 by R near the crack tip. So the answer would be 1 by R. Are you okay, guys, with this one? Hello. Are you guys okay with this answer?
Actually, I'm doing very well.
Just 1 minute. I think some issue.
You don't have to discuss all the questions. Discuss the questions which are very crucial and then which is difficult to understand and problem based. Those type of questions you can discuss rather than discussing each and everything. We can complete it soon and wrap it up soon.
Yeah, the other question. Yeah, this question I am not sure. Could someone please help me? Yeah, like out of all these things, which one is the answer? Hello.
Yeah, even I am reading the question.
Yeah.
Kiranji, I'm on the second lesson so for this week, so I'm unable to help you on this one. Maybe we'll park this question at the end. So if somebody else joins, we can ask the same question. So any suggestion?
Yeah. So the other one, yeah, now you look at this question, J integral becomes some path dependent when crack faces are loaded, crack faces are loaded. Is it okay for you guys? Hello? Are you guys okay with this answer?
Kiranji, actually, I have some different opinion. The first selection is crack faces are loaded. No, I remember sir telling that the crack faces should not be loaded. That means crack faces normally you can call it loaded if pressure acts. So in the explanation, he was telling, at least I remember he was telling that the crack faces should not be loaded. So what is the question? J integral becomes path dependent.
Yeah.
Oh, okay. Okay, sorry. It's other way. Okay, sorry. Yeah, you may be right. Yeah.
See, if you go to which one? Yeah, if you go to previous week lecture, usefulness of J on topic is there. In that one, path dependent of J is there. If the crack faces are loaded or the crack is forward, J is generally the path dependent. That is last week. Yeah, if you refer back to that video, that introduction to J integral, it is there now.
Yeah,
In that
agree.
one, yeah, okay, no?
Actually, this question is not direct; it's indirect. So I
Yes,
read J integral becomes path independent. I read like sorry.
okay, no problem. Next one, which of the following, which of the following criteria allow prediction of crack growth direction for mixed mode fracture? I chose it all. Irwin's energy criteria, it is there, and then yeah, now you can see, right, maximum principal stress criteria is also there, minimum stress, minimum strain energy density criteria also there. So I selected all. Please check this one.
Question number?
Number 4. Are you okay with this answer, or it's better if you can give me some inputs? I will also allow prediction of crack growth direction for mixed mode fracture. See, maximum principal stress criteria, it has both the values of K1 it is there and K2 also there in that equation. Then if you refer to minimum strain energy density criteria also it has both in that equation.
I think it should be maximum principal stress criterion and minimum strain energy density criterion. I'm not sure about Irwin's energy criterion.
No, in Irwin's also, if you refer to that equation, K1 by K1C whole square plus K2 by K2C whole square equal to 1 is there.
But it will not tell anything about the crack growth direction, right? So with the maximum principal stress energy maximum principal stress criterion, we have a formula for calculating
yes,
what is theta.
That angle, correct.
Yes. If I'm wrong, please correct me.
Yeah, that's correct. Actually, whatever you are saying is correct. Because it has the value of angles also to find out so yeah, number fifth question. Fifth question actually I am not sure. See, for this one, he is saying that we can use Irwin's criteria, right? So, which formula you use it? Is it for that circle formula is also there, and then ellipse formula is also there. There are two formulas.
Yeah. If it is a circle, then it will obviously become K1C square. That we can like K1 square plus K2 square will become equal to K1C square.
Yeah.
Yes.
No, but here our intention is
if
to
we
find
start
out
with, we can start with ellipse, but if it is a circle, then K1C and K2C will become same. That's all. So for ellipse, it is K1 by K1C whole square plus K2 by K2C whole square is equal to 1. That is the equation for ellipse.
So
we start with the ellipse equation. If finally we get K2C equal to K1C, then it will be a equation for circle. That's all. Correct. I have also not tried it, but this is my
no, but it is showing if we just do one small check, K1 square plus K2 square is equal to K1C square. If you do that check means, then we can see, right? We can cross verify this equation.
That one also we can do. We can cross verify. That is the case.
So in that scenario, we will go with ellipse equation first, and then we will check this equation.
Because if we start with an ellipse, if K1C is equal to K2C, then it will become an equation for circle. So we can do like that.
Yeah, that is one thing. Yeah, if you don't mind, another student can share the screen and because I lost some power time on my phone.
Okay.
Yeah, the next question. Yeah, match the photoelastic fringes with the patching scheme.
This one.
Yeah, I selected
A,
answer number
yes,
4.
yes, correct. A is 2, B is
Yes, 2, one-sided patch.
yes, B is 3, and C is 1.
Okay. Next year, this one also I have some issue. This TIG building is used for construction of bicycle frames. I'm getting some echo.
Yes.
Yeah, okay. Yeah, so for
this
this problems, do you have some solution or some idea? See, for the problem number 7, I am referring to that PTOD is equal to alpha into K1 square by E into sigma ys. Now we know the value of alpha.
Yes.
Hello, Kiran.
Yeah.
I think there are two profiles logged into this Teams. That's why the echo is coming, I think. Oh, that's
No,
why.
actually, if you don't mind, can you share your screen? I will switch off.
Okay. The yellow. Okay. I'll share it. Second.
Yeah.
Is my screen visible? It's sorry, yeah.
Yeah. Yes.
Okay. How about now?
Yeah. Yes.
Yeah. So.
Okay. Now we go to just we'll go from the starting. Just we want to have some clarification. Yeah, the first one is correct, and the second one, all the fracture criteria predict the same crack growth direction and K1C. Is this the right one? Huh?
I just wrote it. Yeah, I'm not sure because I didn't see the. I mean, when you started discussing, I joined late, no, so I couldn't catch up. What have you?
No, like actually, I did not put any answer for this one. I did not mark against anything. We are not sure. Yeah.
Third question. So, third question.
So
since
actually, for the second question, I have one clue.
Yeah.
It is like if we refer to one of Sir's videos.
Okay.
He has mentioned about the values of these K1.
Yeah. That's summary, you know.
Yeah.
There is the result.
So based on that, the values won't match actually.
Yeah. So if it is the base, there are two theories: maximum tangential stress and strain energy density criterion.
Correct.
So the crack extension angle in case of MTS it is minus 70.6.
Yes.
And in case of strain energy density is minus 83.62.
Correct.
The
Yes.
critical value of K2 it's 0.866 K1C and SCD will be 0.905, right?
Yes.
So
It will be almost same, but
all
not exactly same.
same. So I remember sir was mentioning in that video that although there is a slight difference, but uh, there is no radical change, no? Like 0.86 is zero point 0.9 and minus
Mm-hmm.
80 and minus 83.
Correct.
So we can say that the direction is same. I mean, direction is almost the same. But what about K1C? K1C also,
Actually, okay.
we can predict that the crack growth direction in case of MTS and SCD, it is almost similar. Minus 70, minus 83 means, okay, hardly not much difference, no? But only my doubt is about K1C. What? So K1C,
Little hard to answer. Actually, if we
yeah,
go with the video, then we can say that like as the sir has mentioned, like there is no big difference between the angles, so we can take it same.
yeah.
But if we go with the exact numbers, then we should it will be a different one.
Oh, that way, that way. Like if you're going with the accurate this thing, predict the same, na? Oh, all right, all right, all right. This was I took it as an approximation, like something similar that way. Okay. So is it that you have given D answer?
I had given D, but not sure. I mean, it is there is a chance of discussion
Yeah.
over here.
Correct. Okay. So I think fourth question, as you said, I was listening. So it should be yeah.
The second and third, yeah.
Yeah, because Irwin's synergy criterion, there is no direction predicted, na?
Correct.
Which of the following criteria? Okay. Then fifth one I have calculated using that ellipse formula.
Mm-hmm.
I got something a value of this 51.12.
Mm.
I hope it may be right. I don't know, but because K2 given is 40 megapascal, na? MPa root meter. So which means K2C will be more a higher value. Should not be lower. K2C. They're asking for K2C, right?
Yes. Okay.
If we solve that, if you
Yeah,
K1 by
just a minute. I will also try calculating this.
yeah.
Otherwise, we will do with that option. Is there right? That circle option we can do now. It's a small check.
So as
K1 square plus K2 square equal to K1C square.
No. If it is a circle, then we get both K1C and K2C as same.
Here,
If
since they're asking K2C, that unknown is K2C, right?
Okay.
So basically, you just have to put in those values in that ellipse equation and solve for K2C. So basically, it will be something like that K2 divided by 1 minus K1 by K1C square. I mean, see, it's with scientific calculator and all, it's very easy, right? Because just put the values inside and
But
yeah.
in examination,
Yeah,
we can't use this kind of calculator. So that is the problem.
that's the problem. It will take a lot of time. We have to first actually.
We have to use that online calculator. Yeah.
Yeah, we have to first do K1 by K1C, then find the square of it, then find 1 minus that value, 1 minus K1 by K1C whole.
Correct.
Then after that, you have to find out K2 value of K2 square. Then K2 square whole divided by that 1 minus this value, and root of that will give you that K2C, I think. So I don't know if you got it, Anirudh, like something similar.
Just a minute. Yeah.
Yeah.
Then for sixth question, yes, okay, that you have put the thing, okay. And then what about 7, 8, 9? Like
So yeah, 789.
which
CTOD.
formulas you are using here?
So in the first question, seventh question, since they are asking critical CTOD,
Yeah.
have specified alpha to be used as 4 by pi.
Yes, correct.
So just you can use the equation directly. Delta is COD.
Yeah, yes. Yes, correct. That is correct.
4 by pi multiplied by, you have K1 and this thing, what is that? Young's modulus and sigma ys square.
Okay.
So yeah, only thing is that it is micrometer. So you have this 57.45, it will be into 10 power minus 6.
Yeah.
So that units, again, we have to be careful here because
meters we have to, yeah, it should be in
micrometer. Yes.
So I got some little.
Arjun, I am also getting 51 for the previous one.
Okay, you have got 51, right? Okay, so
yes.
Then we can give some reliability to the answer.
Yes.
Good, yeah. So yeah, so we were discussing that 7, 8, 9, no?
Yeah.
So second question, that's what I just took the formula delta equal to alpha into K1 square by E sigma
into
ys.
sigma ys, yes.
Yeah, so that will give straightforward. And eighth question, okay, they are asking within the confines of LEFM. So there is I had just made a note from what sir's video. So Wells obtained alpha as 4 by pi, which was found to be inconsistent with an energy balance approach.
Yes,
so
if energy balance is used, it will become unity.
Unity, and he subsequently adopted this as universal. So this equation shows that where LEFM is applicable, COD approach is also consistent with it. So within confines of LEFM, I took alpha as 1.
Yes.
Yeah, like Arjun, one question. Here we got 57.45, right?
Yeah.
But for me, I got some.
Okay.
574562, so something I got.
No problem. We'll check. So you have written 4 by pi into K1. K1 is 95, right? 95 megapascal.
Yeah.
So 95 and divided by 200 is in gigapascal. So yeah, I think, let me see this. I think I converted everything into pascals and then did. So
1 minute, I will share my screen. Okay, is it okay? I'm not sure this is right or not.
Yeah, please, you can show it.
No, what I made all the things in the meters I converted.
I'm stop broadcasting. Let me just see. Okay. Your screen, you're broadcasting, no? Because I'm not able to see.
Yeah.
Okay. That is why I have to log in again and again. I don't know.
Okay, now?
Yeah. Now it's fine. Yeah.
Now you can see my screen, right?
Yeah.
See, first, what I did was I put all these values into pascals to get into meters. Okay.
We are unable to see your screen.
Maybe the screen is, the window is not there.
Sorry, I didn't understand.
We can see your screen, Kiran, but the window, the particular window, what you want to share is not there. It's not being shared. Only the
Okay.
This window is shared.
1 minute again, I will reshare. Okay, now. I hope now you have my screen visible, right?
No, the same issue. Only MS Teams window you are
Yeah.
showing.
Okay,
And
now
now
yes.
yes. Excel we can see, yes.
Yeah, okay. Now you see this is sigma ys. I made it into Pascal, and next mod is also I made it into Pascal. Right? See, because this Young's modulus is in gigapascal, right? Because this is in Newton per mm square, no? So I want to keep all these in units with respect to.
I think sigma ys is in MPa. It should be 1e9.
No. See, 1 GPa is equal to 1 e power 9.
That is correct. 1000 MPa is equal to?
Yes, this is where I did mistake. Yeah.
It should be 1e9.
Yeah, correct. Okay, even if you take that also, somewhere I have done wrong.
Pi by 4. I think it is pi by 4.
Pi into E sigma ys.
Sorry, 4 by pi or pi by 4?
No, on this I made here. This 4 into the form I made here. On my side. Yeah. Okay, now you can see.
Yes,
Yeah.
yes.
I think I have made with unit conversion I did wrong.
95 also it will be 95 into 10 power 6 whole square. So 95 10 power 6 will become square. That K1C value, no?
K1C value will become square. So no, you have missed K1C.
K1C. Yeah.
Yes, you have missed K1C value.
No.
Okay, CTOD.
K1C, yeah.
Okay. I got.
Okay.
K1. So instead of, in place of 95, it should be 95 into 10 power 6.
Yeah.
Yeah, okay, that you are making it into okay.
Pascals. Yeah.
Yes. That unit conversion.
Pascals you have to convert. Yeah. Okay.
Yes.
Then it will be squared, so it will become power 12. So,
Okay. I think in this unit conversion is wrong. So, but if you look into these answers, I think it's matching with respect to yours and all, no?
yeah, it will be like in micrometers, it will be 57.45.
Yeah.
You will get the
57.45 and 45.12.
correct.
And then the last one, like in which formula that you have?
So last formula, you use that relationship between J and CTOD, sigma ys into CTOD within LEFM. So basically, you're multiplying this 45.13 by 1000 MPa.
Okay.
So okay,
It should be K1 square by E. That's all I think.
Huh?
K1 square by E, it will be the formula. Right?
K1 square by Oh, okay. You're telling the full. Right. So that's what. So
It's for energy, right? It should
no,
be in terms
Final
of
one is
energy
energy
release rate.
only,
Yeah,
right?
yeah. Yes, sir.
Mechanical
Energy release
energy.
rate. Yeah.
it will be yield strength into the CTOD which you got in the previous question number 8.
Oh, sorry. What is that you are saying?
No, wait. Sorry. My mistake. Actually, it will be like Anirudh said, na K1 square by Young's modulus.
Hmm.
Then again, I was just thinking K1 square is 95 10 power 6 12 divided by 200, na? 200 per 9. Yeah, okay. 45 kilojoules. So, yeah, so what I've understood is that uh, J is equal to G, right? So, G energy release rate, you can use either K1 square by E, or even you can do that J integral sigma ys into CTOD. Both will give you the same answer.
Yes. Both are right.
CTOD that you will take it from.
Yeah, so
Which one you will take?
so you take, because again it's asking LEFM, na? So
Okay.
you take the answer in question number 8, which is
8.
45.13 micrometer,
Okay.
Yes.
and you multiply that by the yield strength, which is this thing 1000 MPa.
Mm-hmm.
So it will be 45.13 into 10 power minus 6 into 1000 into 10 power 6. So that 10 power minus 6 and 10 power 6 will get cancelled. You will get 45125 something. So in kilojoules they have asked, kilojoule per meter square they have asked. So it is almost the same answer. Like I mean the magnitude, whatever, not to confuse, whatever in micrometers we got, same thing in kilojoule per meter square will be the same magnitude, 45.13. I think.
Okay.
Is it correct, Anirudh? Like you got the same?
No, I didn't try, man. Can you give me just 1 minute? I will try.
No, just for even for I think Kannan also can just see. Hope we are getting it.
We can do it here. Can you just modify the Excel sheet?
Yeah, I will do it later. I will do it later.
Okay.
Now I got this theory. Actually, I did some mistakes in this one. Unit conversion is wrong in my case. But I will do this one.
Okay.
Okay, this is one thing. So now questions. Yeah, 7, 8, 9. It's okay for me. How about others?
So I think it's better to again refer to that Prashant Kumar book, and basically we have to use that. There is a stress transformation law, because this there is a mode 1 and mode 2 both. It's a mixed mode condition, no? So we have to use that stress transformation law to find out what is the stress acting perpendicular to the crack direction, and what is the corresponding shear stress also. So
in this one, I have one. Okay, now we check my on the answers whether.
Yeah, it's something similar. Yeah, got the only 13th I got 78. Yeah, rest all is correct. 13th MT, what is that? Maximum tangential stress, no? Let me just see.
Or else I might have done wrong.
No. We can verify that so that. Okay. Yeah. So.
See, to get that maximum. See, if you refer to that book, Prashant Kumar's book, there is one example given in page number
Page number?
That is example 7.3.
7.3. Okay.
That to find the critical applied stress, sigma 0 critical, corresponding to crack initiation. So we have to follow that MPS criteria and substitute the value of K1 and K2 in the equation 7.9.
It is this sigma theta theta equal to 1 by root 2 pi r cos theta by 2 K1 cos, that one only, no? Cos square theta by 2 minus 3 by 2 K2 sin theta.
Yes, correct. Yeah.
So I
RR equal to K1.
So this, I mean, just so that to confirm with everyone, 1 by root 2 pi r, can we take it as 1 by root pi into a?
Yeah, in this one, see, we have to take this formula. If we go to that question,
Yeah.
yeah, in this one, it is showing,
Correct.
yeah, here, yeah, this one number second. To find critical applied stress, sigma 0 critical corresponding to crack initiation. To determine sigma 0 critical to MPS criteria, we substitute K1 and K2 in equation 7.19. Okay, if we go to that 19, yeah, this is the one.
K1 cos square theta, 1 second, K1 cos cube theta c by 2 minus 3 by 2 K2 theta sin theta is equal to K1c. Okay. Kiran, we can take 11.17, no? And solve it for sigma theta theta max.
For obtaining failure surface independent of this, we substitute equation 11.18 in equation 11.17. See, again, you will have this equation only, right?
Okay.
Finally, you will get the same thing only.
Yeah.
See, now you know the values of this one already.
Yeah.
K1, K2, you already know. And K1C also you might be knowing. Yeah, in this question they have written, right? Yeah. K1C they gave.
Yeah. So,
K1, K2, yeah.
Just that the unknown which we have to find out is this sigma theta theta, no? That.
Yeah. Sigma 0, yeah.
Yeah, sigma
Typical.
theta theta. So, I think that 11.17 you have to just solve for sigma theta theta, and I think it won't be. Yeah, so 11.17 is there, no? Yeah.
Okay.
That one. That's what I wanted to just confirm that here that K1 by root 2 pi r naught is there, no?
Okay.
I have taken it as K1 by root pi into a. Don't ask me.
No, this R not from where you got that value?
No, that's what I didn't take R naught, or I took it as K1 by root pi into a. A is 40, like 2a is 18 millimeter. No, that's what you have to see. I had gone through many textbooks because I had the same issue, because R naught is there when you have a radius from the crack tip to a particular point which you want to find out. Like
Okay.
that we say that you take crack tip as the origin, and then you want to find out what is the that displacement or stress field at a distance of radius away, etc. No, so that was the confusing point. So somewhere I referred that you can take it instead of 1 by root 2 pi r naught, you take as 1 by root pi a. That's why I just wanted to confirm with all, check with all, because I had the same hiccup yesterday, and that's what.
So there are two options.
Hmm.
See, one is we can go with this MTS criteria, and another method is to go with this SCD criteria.
No,
Strain energy density.
we have to use the MPS only, because the question is asking that, no?
It's the 12th one,
Yeah.
initial crack growth
That in
direction.
according to MTS criteria, at what value of correct.
Yeah, so we have to use that formula only.
Yes, we will go with the equation 11.19, which says this is the one. Yeah.
So that maybe you can just check it up. Anyways, I had got a value of 78 megapascal for 13.
Yeah, 1 minute I will not 78 megapascal.
78. Yeah.
Yeah. 78 point.
No.
Yeah, it's only 78.
Yeah, 78 megapascal. Yeah.
Okay, and for the rest of the questions, is it according?
The rest of the question again, that Irwin's fracture criteria, I got. That's what I got. K2C as 18.61.
No,
So
in this I have one. Oh, really? So this
yeah.
question number 14 and this
Yeah.
fifth one, you will have this same equation. Huh?
Same equation. Yeah.
Okay.
Only thing is that what I noticed is that when I solved question number 14, I found that the see, one thing is very clear: your K2 value has to be less than the fracture criteria K2C. So K2, as you said, I got the same answer, 18.42, and K1 is also 10.63. 12th also I've written as minus 60 only. But if you calculate using that ellipse formula, you will find K2C as 18.61, slightly greater than the K2 value. So I had I checked, cross-checked twice also, and I was getting the same value. Maybe you can just calculate again using that ellipse formula. K1 by that formula, K1 by K1C whole square.
So only thing is we need to check with this MTS criteria.
I had referred to Broek actually, because to find out that 1 by root 2 pi r, no, that took me a lot of time. I'm trying to find out that page from where I took that. If I get it, I will share with you.
Okay. I think I have rechecked this question. So, but anyway, I have noted down your answer so that I will again recheck and I will do. And for this one is on this question answer is in
Which one?
18.61. On 18.61,
Yeah,
right?
yeah.
That you referred? Okay. Okay, I will also check. So, okay, apart from this, which one is the more critical one? This one here. This one? Like someone will go with option 1 and someone says option 4.
Yeah, that question. So, what is it? Which of the following? No. Choose the correct statement with reference to different fracture criteria. I think we can just see that video once and that where sir says. No, I think we have to take it subjectively rather. I think I'll tell you because I think the last video that which is the one. Yeah, lecture 40, crack arrest and repair methodology. Before need for crack arrest, delay in crack reinitiation, sir had summarized the values.
But in the video it is for K2C. Can I share my screen? 1 minute.
Yeah. Yes.
Sorry, I am unable to share. Sorry, I am unable to share. I don't know why.
Anirudh, do you want to share? Do you want me to share on your behalf any other course notes? I can do that.
Yeah, as Arjun mentioned, it is there in that lecture 40.
Okay, let me share my screen.
Lecture 40, page number 7. Yes. So in this one, crack extension angle theta is mentioned for 2 different theories. But the critical value, it is for critical value of K2, not K1. So we are asked in the question, what about theta and K1?
But this is only for mode extension, no? This one? But the question is for, right?
The question is for mode 1, I think.
Anirudh, so if K2C value is changing for 2 theories, so can we say that the K1C value is same for both?
No, I too don't know. I had the same. I mean, I had the same confusion. Like, how can we use that value?
Okay, sir was mentioning because that K1C value we have to use something because K1C value will be similar for if you consider mode 1 alone. This we are doing for mode 1, mode 2 combined, na?
Correct.
But K1C value should be the same for both. Somewhere I had listened.
Okay.
Yeah, just I think that video only. It was a bit confusing, but yeah. Maybe Prashant Kumar thing may be given. But
Okay.
so yeah, one thing is there, Anirudh. So here, although the degrees are changing slightly, minus 70, minus 83, 13-degree difference, but at least we can be sure that the direction is the same. Na? Direction predicted by both are same. The exact angle is not same, but
Correct.
the direction is same.
Yes,
So
yes.
we just have to identify whether if it is A or B option. That is predict the same crack growth direction and K1C, or predict the same crack growth direction but different K1C. I think we can localize to these two, A and B.
Yes, correct.
Yeah. So yeah. And again, as I feel that since for MTS and for both strain energy density, K2 is nothing but a factor of multiplied by K1C. So it should mean that the K1C value should be same for both, I suppose.
Okay.
Okay, but one thing is there. So if we see this SCD criteria and the principal stress criteria, that value of K1C, there is a formula given na, for finding out K1C for both criteria. So that we have to see, because if it is the stress and strain energy density, it is K1C is equal to 16 G pi by 2 kappa minus 1. It goes on, right? A11 K1 square. So if it is a stress criteria, it is K1C is equal to K1 cos cube theta m by 2. So unless we do an actual problem, we don't know what is, whether the K1C value is same for both criteria. No. Now since you mentioned, I'm just thinking. It is before that, previous slide. Can you just scroll up? This one. Yeah, this is what I was saying. For K1C calculation for two criteria, the formula is different. So
Team, the second question is for mixed mode, correct?
second, yeah, it's for mixed mode.
Okay.
So that's what I was thinking. Now, since there are two different formulas for finding out K1C for two criteria, unless we find out in a problem whether if it is coming similar or not, so I think we have to go back to the text only to find out what is the real this thing.
So generally speaking, it cannot be same, no. AC cannot be same for two criteria.
Yeah.
And the direction is similar. So second is the most reliable option, is what I feel.
Correct. Yeah, second seems to be a better one, na? Because K1C value will change for both criteria. Okay. So maybe we'll go with the second option, predict the same crack growth direction but different criteria. But if then somebody, if any one of us, if you find out something, then please do post it on the forum so that it will be easy.
And share my screen?
Yeah. Sure.
So that's the end of this week's assignment.
Yeah.
Can I discuss something else? Any other questions?
No, apart from this, I have no question. So, in this case, I think
I have a question regarding this 10th and 11th problem.
Okay. Okay. Yeah.
The mode 1 SIF.
Yeah.
So
Yeah.
for this one to calculate, how we should proceed? Any idea?
So that so I'll just tell you this thing. I mean, how I found out is that now there will be both there will be both normal stress and shear stress acting,
Correct.
because the loading the crack orientation is like that, 30 degrees, no?
Correct.
So
Correct.
what I'll do is I'll just share my screen.
Sure.
Yeah. So okay. Right. Yeah. So this screen you can see now.
yes.
So here basically the first one, that image x1 x2 sigma naught, that is the configuration of the problem. Okay.
Yes, correct.
So that if you do the stress transformation, basically okay, sigma naught is given as the that value which is given in the problem. How much megapascal? You can just,
Yes, yes. Sigma
yes,
naught is whatever is given.
120.
Sigma 120.
Yeah. So yeah. So then, so you know that sigma 22 is the one which will, it is a mode 1 condition, which is a normal stress, sigma 22.
Correct,
Sigma
correct.
point,
Yes.
yeah. So you just do sigma naught, the value given multiplied by sine square beta, which is sine square 30. Okay. So you get value of sigma 22, and then you find out what is the shear stress. Shear stress tau 12, which is nothing but sigma naught sine beta cos beta. Okay.
Okay.
Then we have to substitute this formula in this equation.
This. Okay. Oh, okay, okay. Got it, got it.
So sigma 11 is 0 because it is a uniaxial load only. There is no biaxial load. But because
Correct.
of the orientation of the load acting, you will have a shear stress component. That's why
Correct.
it is a
Exactly.
mixed fracture.
Yes.
So you can use this formula and find out K1, K2. Then what is the next question? Then the initial crack growth direction. So here you can apply that tan theta formula.
Yes,
tan
that
theta,
MTS.
Yeah, yeah. So here again there is a small. So basically you will get two values for theta. Because the formula goes like tan theta m by 2 is equal to 1 by 4. Where is, I'll just let me see.
Yeah, plus or minus will come in between.
Yeah, plus or minus. So so here basically, I mean, this is a different example. So you have to neglect which is so I had taken, so one you will get as positive and one you will get as negative. But sir had mentioned in that video that crack will be with respect to the crack axis, your propagation will be downwards. So that's why I took negative.
Okay. Maybe yes.
That formula is clear. That tan theta m. I mean,
yeah. That tan theta is. Got that formula, but
1 second.
and even in sir's videos also, if we see all the values which he has taken for this crack growth direction, it is in the minus direction only.
Yeah, because it's assumed that the crack is, in the positive x direction. The crack is, it is propagating downwards. So keeping that x-axis as reference axis, it is going downwards. So that's why he took negative, I think. So took negative.
Okay.
So, okay, I'm not able to find the formula here. I think it's there in the notes only. Anyways, so
Yes, it is tan theta m by 2 is equal
yeah,
to 1 by 4 k1 by
by
k2
2
plus or minus 1 by 4 square root of k1 by
k2 whole square
k2 whole square plus 8.
plus 8 plus 8. Correct. So, so first condition we can take a plus and then do tan inverse of
Hmm.
that value and multiply by 2 so that you will get theta n. Second, you have to do minus and then take tan inverse of the value and multiply by 2.
Yeah.
So I took the minus 1 and I think Kiran also got the same value.
Okay.
And yeah, so this one is that sigma theta formula, na 78 MPa, which I according to
Yes.
maximum.
No, like if you have that Prashant Kumar sir case there means then you will easily understand. Like we do one example, right?
Yeah. We saw that
Prashant
formula.
Kumar sir.
Uh, okay, because I have taken, I mean some formulas I took from our notes and some especially for the stress transformation I had referred to Prashant Kumar's book, but the other formulas are not. I think this one. Yeah, you can take this formula.
Okay.
Okay. So this only difference is that yeah, sir has taken cos theta c by 2 outside and then given the formula.
This one. Okay.
I mean, yeah. Then yeah,
This is
K1.
1 by square root 2 pi r naught is there.
So that's what I'm searching in this Broek. Like somewhere I had seen yesterday. Something I was looking something like this. There was somewhere he had arrived because we don't want, because there is no radius given, na, where
Correct. R naught is not given.
yeah. So I was looking at some reference like this, sigma root pi a. So I have done by multiplying root of pi into 40. This somebody can confirm it also because time was a bit short. Yeah, see, somewhat like this. We can see here, it is all taken sigma root pi a, sigma root pi a. I'm not able to get that concept now. How to correlate 1 by root 2 pi r and root pi a.
Maybe in any of our previous lectures, is it given? I was thinking.
Yeah, that's what. See, I was just skimming through now, so that's why I was not getting. But yeah, if you can go through, it will be nice. So I was just going through
Actually,
where.
I do remember about this R naught thing, but
Yeah.
I was not finding it.
That R naught, yeah, R naught thing I'll show. I'll show how it where is it? Yeah. See, this is the case wherein you want to locate at a distance r from the crack tip. But we don't have a r, no.
Correct.
We want to. So in this, r means when we go back to our previous class, sir had mentioned you shift the origin from the center of the crack. Sorry, yeah, from the center of the crack to crack tip, then find out r like that. But here it is like we are considering as just half from here. Our origin is at the center of the crack only. So it's something to be looked at. Yeah. So that's why I took it as 1 by root 2. What is that? 1 by root pi a. Root pi a. Yeah. The same term. This root pi a factor, na. Many places. See here also. If you see, they have given sigma c is equal to K1c by root pi a. So yeah, I I don't know the concept. I don't know, but we have to go through actually. I don't remember it. Kiran, any suggestion? Like,
No, I actually.
okay, yeah.
Okay.
Even this book also I read.
If I find something, I will post it.
Please,
Yeah,
please. Yeah.
that's correct.
Okay. So I think so. That's about it, right? So. Any other question?
Arjun,
Yeah.
can you share the book actually? You showed the figures. Sigma 1122.
Oh,
And
okay.
you're saying that
The formula or the book?
the book. It showed the.
No,
Prashant Kumar.
Prashant Kumar book you need or?
Yes, Prashant Kumar.
Okay.
One minute, I will try to post it in this chat itself so that you can copy and paste. Yeah, it's only. Yeah.
Can you put a figure that sketch?
Sketch,
you were telling that sigma 11 will not exist, right?
Sigma 11. Sigma prime 11 will not exist.
Please be careful because I have a different book.
No, I'm not. I'm sorry. Sigma 11 value will be there, but it's not significant here because we have to find out. See, basically K1 is nothing but sigma naught sine square beta is nothing but sigma 2 sigma prime 2. Okay, and for K2 sigma naught sine beta cos beta is nothing but the shear stress tau 1 2. So that's why I said that although sigma, okay, I'll put a sigma 11 is there, it is not used in our stress intensity factor calculation.
Okay, fine. This is what I.
Yes, correct. You're right. See, so it is a uniaxial stress field given the problem, but because of the track orientation, it will in effect be like a biaxial with a shear stress.
Yeah. Thanks.
Yeah. So.
I think I am unable to post this one in this chat itself. I don't know why it is not allowing me to.
No. I think in this what is that? 1 second.
Okay. That the link you are.
Yeah.
I have it. No problem. It's not open with me at the moment. I have it.
No, that one is available. If you just type PDF, no?
PDF.
Prashant, PDF, it will come from Neem Rana or something like that.
This link.
Yeah.
Link.
That one. SON.
Yeah, okay. This is the problem. I don't know why I have to.
Yeah, this again and again we have to rejoin.
You are also facing. Okay, I thought I was only.
Yeah. No, I am also. Yeah, I also have the same problem.
Okay. Right now.
But I'm not just for information.
There is a chat box. Yeah, there's no.
Yeah, if you see no.
Chat box is not there. Huh? I mean, since I'm presenting, I'm able to.
Or else, I think Kannan needs that book.
Yeah, Kiran, if you can just paste it in the chat.
No, actually, I am not able to do anything. That's the problem. I have that book readily available. So I don't know.
You can just search in the search bar like this, yeah. Prashant Kumar Fracture Mechanics PDF, and choose this one, this link. Sonam, Neem Rana.
Som Rana, something like that.
Yeah, this is directly a PDF. You can download it as it is. So yeah.
Yeah, ma'am. Now you can stop recording.
Okay.
So you guys are done discussing?
Yeah, that you stop recording so that we can talk any other things. The normal discussion. So with this, I think our course came to an end, right? So we have another class.
Will we have any other class in the next week?
Yeah, one I'm thinking.
Overall, we can.
Yeah, one on weekend just before the classes, just before you guys have exams. That time I'm thinking like if you guys have any problem, you can send me a mail. I'll prepare only those questions, those who have mailed me.
Okay.
We can have both Saturday and Sunday also if you guys want. Even tomorrow I'm free actually. If you guys want, we can have tomorrow also discussion.
Okay, ma'am. Tomorrow. Okay, please. Whenever you're free, ma'am, please post the link.
Post it, yeah.
Yeah.
Post the link.
We'll somehow make time. I mean.
You can let me know anything particularly related to metallurgical aspects. If you guys are confused, then you can send a mail to me and then I'll prepare those things and then I'll discuss those questions. Mechanical, it will be a little bit difficult for me to discuss, but metallurgy for sure I can help you guys out.
Ma'am, just one only small thing I want to ask. You had mentioned that sir had told that we'll be given a sheet, no, with formulas. So
not sheet, in the
question itself.
Yes, in the question itself.
No, like what I came to know is before starting this exam, right?
Yeah.
And you just enter all your this ID, everything and all, no? Then immediately on the screen, you can see all the formulas list. Okay, then immediately that you have to, that immediately that you have to note down on a paper.
Okay, okay.
This is what that information I got from my friend.
Right. Understood. So, okay, so after that, while answering questions, we can't go back and refer that.
But I am not sure. Yeah, like initially it will appear on the screen.
Okay.
Once you start the exam, then it will go in the flow.
Understood.
Maybe it is possible, okay, to go back and refer back to all those equations. So, but one thing is, you may not find at all these equations.
Understood.
Only that big equations are there, right?
Yeah.
Only those equations it will be available on the screen.
Okay.
Kiran, I doubt this actually. Because I've taken last year exam, but there is nothing like that what you specified. Some cases, some questions, it was there in the question itself, especially the long formulas which you cannot remember.
That's correct.
This is what Himam told a couple of weeks back also.
Okay.
Maybe you joined late in that meeting.
Okay. Actually, I was not there.
In case if there is a change in strategy with respect to NPTEL, then this may be available. But based on last year's experience, there is nothing.